So we often want our code to work and do stuff based on the context around the code. We call this control flow in computer science. We'll start with the if statement. So an if will operate by checking if a condition is true and then doing something. And then otherwise, you can also say do something else. So to build up to our if, we're going to start by reviewing logical operators. If you already feel very confident with our logical operators, you can skip that section. Then I'm going to introduce if and else statements, and then their vectorized cousin, if else, which works with mutate. So back to our logical operators. We have and, or, not. We call not means the opposite. So we say not true, we get false. We say not false, we get true. Now in code, we're not going to have true and false in our if statements. We're going to have conditional statements. So the first thing you got to do is understand how to unpack this kind of statement. We have 2 greater than 1. That's true. And we have a not. Not true is false. Take a pause and try this out. So we have not 0 does not equal 0. But we know 0 does not equal 0 is false, and we know that not false gives us true. Logical OR returns true if at least one term is true. So here we see we have one term true, true or false, so we get true. In the second example, we have false or false, so false is the result. See if you can do this one. So we break it down. We have 5 greater than 7, that's false. Then we have an OR, and then on the right side we have 10 equals 10. That's true. So we have one true, at least one thing is true here, so the whole thing is true. Now, and returns true when both operands are true. So we have true and false. Well, we have a false thing, so the whole thing is false. The second example, we have true and true. The whole thing is true. Both sides, both operands are true, so we get true back. Now here's a challenge. Maybe pause your computer for a second. So this looks scary, but let's break it down. First, we know if we can evaluate this and the first term is true and the second term is true, then the whole thing will be true. And if either of these is false, we're done. So on the left side, 2 greater than 6, that's false. So then we say not 2 greater than 6, not false is true. So on the right side we have true, which means we have to evaluate the next thing. Now here's a nice thing about and. If we got false on the one side, we're done. We know the whole thing is false. So breaking down the right term, 4 greater than 9, false. 3 equals 3, true. Put that in an OR statement. If we have something true in an OR statement, the whole thing is true. So we have true. So if we go back to our original complicated expression here, we found that this was true and this was true. So then the whole thing is true. So now we can put our logicals to work in if statements. Here's the general syntax. We have if, and then in parentheses, we have a condition. So that's 2 greater than 1, or in this case, x greater than 0. So in the parentheses, we have a condition, and this should return true or false. If it's true, we go into the brackets, and R will execute the code here. So in this case, we have x is 100. We test if 100 is bigger than 0. That's true. And so then R will print this statement. If we set x to negative 100, R is just going to skip this statement. So it's going to say, if false, okay, I'm not going to do this thing. If we want R to do something in the false condition, we have else. If our condition is true, we do this. Otherwise, we do the other thing. So here is a very common use case. Let's say you're working on a project with a partner. For example, Terrence and I are working on Coding Lab. And you want to be able to run your code that relies on data that has a different address or path on your computer than on your partner's computer. So the condition here says if, and this is basically a way to ask R if I'm the user. If the user is Ari Annisfeld, then we're going to set the base path like so. Otherwise, we'll set the base path like this. And then we can use base path in our read CSV and get the data in on both our computers. Now, you might want to test multiple conditions, and we have else if for that. So the way it works is we test the first condition like before. If it's false, we go to the second condition. If that one's true, we go and we execute the code that says do this other thing. If it's false, we try the third condition, and if that's true, we do this third thing, and else is still a default behavior. Notice that if we do something, we're not going to check the other conditions. So we're going to leave and exit the control flow. So let's put this to work. So here I have developed a very simple game of blackjack. Here are my cards, here are the computer cards. When you get code like this with new functions you don't know, it's great to put them in the console and to see what happens. So if I run this code a few times, I see I'm getting a random number, and what's happening is I'm sampling between 2 and 11. Again, if you forgot what the colon does, just type it in. I'm sampling from a vector between 2 to 11. I'm sampling one number. So, you might think you understand that this second number tells you how many cards to pull. So let's just test it. There we go. We got two numbers. Great. So now I have my cards. I have my computer cards. Over here in the environment, we see with this random draw who won. The computer has 16 points. I have 10 points. So in this case, the computer would beat me. How would we tell the computer to test this? Well, we'd say, hey, if my cards are greater than the computer's cards, then I'm going to print, you win. And let's say I have a bank over here. I'm going to add one to my score. Now, what could happen otherwise? Well, either I could lose or we could tie. So let's do the next one. We tie. So if our cards are equal, we'll say it's a tie and no change to the score. Finally, the worst case scenario, if I didn't win and we didn't tie, then I lost. So I'm going to say print try again next time. And I'm going to take one away from my score. All right, so let's run this. We see my score went down in the environment here, and the computer printed out, try again next time. So let's try again. Let's just see how this goes. I get my cards. I get the computer's cards. It looks like I lost again. Let's try again. All right, so this time it looks like I won. I got 22 though. If you know blackjack, you have to get less than 21 points to be the winner. So if I run this right now, I'm going to win, even though in reality I should have lost because I went over the limit. So we can change the first if statement to double check and make sure that I didn't bust, as they call it. So I'll say, and my cards are, what should we put there? Less than or equal to 21. So now with my same score, we see that I lost. Now you might say, wait a second, the computer also could have had over 21 and then you should have won. So then we could have an OR statement. We can say computer's cards are greater than 21. So now we have the first thing check. If my cards are greater than the computer's cards and my cards are less than or equal to 21, I'm going to put this in parentheses just to make it easier for us to understand. That's the left side of my OR statement. In that case, I win. Or if the computer busts, I also win. And notice this sets up the rule so that anytime the computer busts, I win automatically, even if my score is over 22. And that might be what you want. It might not be what you want. Depends on the rules that you're playing by. There's two more things I need to tell you about if. First, it can't handle vector input. So here, I give if a vector with true and then false. So it gives us this warning. It says the condition has length greater than 1, and only the first element will be used. So if we look at this code, we see if, and it just sees true. It ignores this. And when it's true, it does execute the code here, and that's why we get the output if true. The other thing about if is it can't handle NAs. If it gets an NA, like in the second example, it just gives you an error, and it will tell you it needs something to return true or false. So what are solutions? I'm going to start with NA. So here, I create a condition called my condition, which could be NA. In this case, it will be NA. If I run my code, I get the same error. Notice that in my previous example, the name of the condition was NA, and here it's called my condition. So the result isn't quite as clear when you're actually working with real code. But you get the same error. It says missing value where true or false needs to be. So the missing value is NA. Okay, so what can we do? We can first test if the thing is NA, and then we can do the other thing. So I'm going to say if, and then the way to test for NA is .NA. And if so, we're going to do something. If I want to do nothing when my condition is NA, I can leave this blank, so nothing goes here. I do need to put the if-else part on the same line, so we can reformat it to match what we've used to. So it prints null here, which will have no effect on your code. If you want a warning, you could put warning, my condition is NA, and that will print out a warning message like so. So that's how we deal with NAs in this kind of control flow based if statement. What about the vectors? Well, we have a separate function for vectorized if called if-else. If-else has a test in the first position, and if the test is true, we have a result for yes, and otherwise we do no. So here's an example. I use sys.date to get today's date, and then I ask if else today is November 3rd. If yes, I implore you to vote today. If no, I have a reminder. So if I run this code, I get don't forget to vote November 3rd. So right now, if else looks just like our control flow version, except that there's less syntax. There's no curly brackets, which is nice. More importantly, if else can handle vectors. So to get there, let's start with a very simple example. If else true, we're going to print 1. Otherwise, we'll print 2. What should this code return? Exactly, it's 1. Now, we're going to say if else false, 1, 2. What should this code return? Louder for the people in the back. That's right, it's 2. Now let's put that into a vector. We got true, we got false, and let's put another false. Why not? So we have a vector with true, false, false. And I told you that if else is vectorized. So what should happen? When we have a vectorized function, it will operate on the input one at a time. So we'll have a response for true, a response for false, and then another response for false. So we should have an output with 3 numbers. The first one should be 1, and the next 2 should be 2. And that's what we got. Because if else is vectorized, it's particularly well suited for mutate. So here we have an example. We take Texas housing data and then mutate it and create a column called in January. That column is going to have the result of this if else statement. If else month equals 1, we'll put true, otherwise false. Now remember, month is a column in our data, and a column in our data is a vector. And so for each month in our data, we're going to test if it's 1. And if it's 1, we'll put true. We see that in the first row. Month is 1, in January, true. For the rest of the rows that you can see, these aren't January. These don't have month equals 1, and so we have falses. As you start coding, you're going to have a time when you're going to want to have an if-else statement with a else if in it. Like you want to test one thing, and if that's true, you do it. And then otherwise, you want to test another thing, and if that's true, you do it. You could start nesting these if-else statements, but that's going to lead to code that's very difficult to read and hard to debug. So rather than nesting if-else statements, we have case when. It works like an if, else if, else if, else if statement. After the tilde, we have the result that we do if the statement is true. And if the statement's false, we go and check the next statement. So we'll check each statement in a row. Once we say something is true, we're going to take the thing after the tilde, and then we'll check the next median price in our list. So we see in the early 2000s, Abilene is mostly first quartile. This doesn't really help us test our code because we only see when the first quartile works. So we could, maybe filter the data. Let's look for a time when the median is greater than 100,000. Here in the mid-2000s, Abilene has higher housing prices, and these are in the range for our second quartile. So if that's not convincing and you're wondering, are we really dividing this evenly? I'm going to preview a function that's going to happen in the group by lecture, which is count. And we could say count housing market. And here we get the number of observations or number of rows that are labeled with each of the quartile labels. We see there's about 2,000 observations in each, so that's pretty good. And then one thing that this helps highlight is when we don't have data in the median, we're going to get NAs. The last thing I want to point out is that case when's a little bit surly. So notice that these are all characters. If I put a number here, I'm going to get an error. And the error says, must be a double vector, not a character vector. It's kind of hard to understand, but what it's saying is when you make a new vector with case when, it needs to have the same type, and it can't do type coercion. So the first house was a 1, and so it expects only numeric, or in this case, doubles, but then it starts seeing characters and it throws an error. So now you have a good sense of how we can use if and if else to do things conditionally based on some aspect of your data.